Okay, so here we are in our R studio, and we are going to analyze our experiment of 24 subjects entering text using the iPhone keyboard or the Samsung Galaxy keyboard in different postures, that is, while sitting, standing, and walking. And this is a factorial ANOVA, meaning there are multiple factors, in this case 2, as we've discussed. And there's a between subjects factor for keyboard and a within subjects factor for posture, which is also known as a repeated measures factor. So we'll be doing a repeated measures ANOVA because if you have any within subjects factors, then ultimately you're doing a repeated measures ANOVA, even though we're a mixed factorial design here. We'll be looking as well at interaction effects and ultimately a non-parametric version of these analyses as well. I have a note here that mixed is a term that's used in multiple ways in the analysis of experiment data like this. And we're talking about a mixed factorial design. But that's not the same thing and not to be confused with mixed effects or linear mixed models, which we will be getting to later in the course. So read this note and just make sure that you're clear on mixed designs mean we're combining between and within subjects factors. So let's progress through our analysis as we've done in the past, and we'll see familiar patterns of exploring the data before analyzing it. So we'll read in the mobile text data file, and let's take a quick view on that. I know it's small on the video, so I'll tell you that the column names are subject, keyboard, posture, posture order, because that's a within subjects effect, and we want to make sure that we have no order effects, that our full counterbalancing worked. We have words per minute as one measure and error rate as another measure, which is between 0 and 1. It's effectively a percentage. All right, so let's recode, as we always have done, subject as a nominal factor and posture order as well, because those are both numbers, and by default R thinks that they're numeric values, but they're really categories. And then let's move through our usual analysis of the words per minute data in this case. So we can see by Galaxy and by iPhone here, and by posture. So we see in our output Galaxy and posture, Galaxy and sit in the first row, and we can see various values for that. And we can do the same if we want to look more closely at the means and the standard deviations. And so when you have two factors like this, you end up with a table that shows you kind of the mixture of each of the levels of the factors. We can also walk through our histograms, now looking at two factors at one time, and just get a sense of the shape of the data. And we can see so far, at least for the iPhone, words per minute look, at least somewhat normal. We can look at the Galaxy while sitting, while standing, and while walking as well. And we can use the box plot command to actually graph all of these at once. So on our x-axis, we have keyboard by posture combinations and words per minute on the y-axis. And you can spend some time with this graph and study where you think differences may lie. But nothing beats an interaction plot, which we'll do next, to show us what might be going on in terms of these three levels and the keyboards. So here we can see there is clearly some visual gap between the sitting condition, also between standing, and also between walking. It seems that walking certainly slows people's text entry speed down. Standing and sitting seem to be roughly about maybe the same, but different for each keyboard. So based on our discussion previously, it's pretty clear we certainly have at least some kind of interaction. Another way to put that is the lines are not all just parallel, so we know something differential is happening. So let's go ahead and use our easy ANOVA command. So we'll load in the easy library, and recall with this that because we're doing a within subjects factor here for posture, and first we'll do posture order as well, that we want to make sure that, that we're not violating the sphericity requirement that we explored previously in the class. So we'll do that with Mauchly's test of sphericity. First let's look at a potential order effect. So we'll look at posture order as our within subjects term. Keyboard is our between subjects term. Our dependent variable, that is our measure, is words per minute. Our within subjects ID is subject, so that's what codes across rows of our table saying that the same subject was measured repeatedly. And then our data table. So let's go ahead and we'll store that in our model M. And then our first look is at the Mauchly's test for sphericity. And we see that we are not statistically significant for our within subjects effects. And that means that we don't have a violation of sphericity, so we can just use our regular ANOVA table. So when we examine that, we see that we have a main effect of keyboard, but the key part here is posture order and its interaction with keyboard we don't want to be significant, and we can see, in fact, that they're not. Take note that this is using scientific notation, but it's a non-significant result. There's no star in the column. That's another quick way to see it. So that's good. That means our counterbalancing worked, and we can go forward with an analysis with confidence that we're not confounding the results by the presentation order of the different postures. Because remember, again, each subject did all of the 3 postures in the assigned orders we gave them. So let's do the ANOVA now on posture. So we're doing the same thing, but we've changed the within subjects factor to posture, not posture order. Otherwise, it's the same test. So we'll do that, and then we'll check our Mauchly criterion, and we see now that it is significant. So we have a violation of sphericity, which means we'll use the degrees of freedom provided by and the significance results for our within subjects factors provided by the Greenhouse-Geiser correction. So we'll first look at a ANOVA table because we do want to look at the keyboard between subjects factor here, and we can see that is statistically significant. And we can tell that from the graph, that there's clearly a difference in the keyboards. While in sitting, the iPhone keyboard's not as good, not as fast, I should say, as the Galaxy keyboard. For both standing and walking, it's a fair bit better, especially with walking. And so we're not surprised to see there is a difference in keyboards. We'll go ahead and load up the results for the within subjects factors in the sphericity output here. So here we're getting our effect significance from the corrected result. So we have posture and the keyboard by posture interaction here. And we see that our p-values are, in fact, statistically significant under the Greenhouse-Geiser correction. And we get our stars in that column. We'll ignore the Hunt-Felt correction here. It's just an alternative correction. And then we get our degrees of freedom in the remaining output. So our numerator, degrees of freedom for the F test, is here, and we might round that to the nearest 10th or 100th when we report it. Our denominator is here. Notice those are corrected from the uncorrected values up here. And so that's why we get the fractional results. And so those are the terms we'd use to report those outcomes. So the bottom line is we have 3 significant results. We have a main effect of keyboard, a main effect of posture, which is no surprise. Clearly walking overall is slower than the other 2, for example. And we have a main effect, an interaction effect that's significant where we have differential things. And we can see that in the crossing of the lines there, and they're not exactly parallel elsewhere as well. So all 3 are significant. That makes for an interesting set of findings. For completeness, we can do the analysis with the AOV fit, but that wouldn't give us the Mauchly's test of sphericity. So I won't run that, but I included it for completeness so you can see how the usual model specification is done. The easy ANOVA function makes a lot of that a little more straightforward, which is why we used it. So now we can do comparisons in light of the significant interaction. We want to see, well, okay, the overall or omnibus F test was significant, but let's do some looking between levels. For example, how do the 2 keyboards compare when sitting? How do the 2 keyboards compare just when standing and just when walking? Those are some of the things interactions can answer for us. So we have to make a wide format table, so we'll use the reshape library and code our table to be split with dcast and made wide. We want to keep subject and keyboard as between subjects columns on the left side, and posture becomes the new column names for the wide table. So you'll remember we went through that previously. So we'll make our wide table, and then we'll view it just to make sure that it looks correct. And we have columns for subject, keyboard, and now sit, stand, and walk. So the posture factor is encoded as column names. That's what a wide format table would give us. Now the subject variable is just one time in each row. Each subject's listed just once per row. Now we'll load up the tests comparing the different postures in the different levels load up the test for comparing the keyboards in each of the 3 different postures. So we're comparing these 2 data points, these 2 data points, and these 2 data points to see where do the differences really lie, and then we'll adjust those using the home sequential Bonferroni procedure as we've done before. So we'll run all those together, and here we see that in fact all 3 are statistically significant at the 0.05 level. And so all of these differences are big enough in light of their variance that we can say that whichever one's on top, so to speak, in this graph really is faster. We also might be curious to say, well, what about within the iPhone? How might we compare the iPhone in terms of sitting to walking? So we can see the iPhone sitting here. If we go over, the iPhone's walking is a little bit slower, but they're not too far apart. What might we see there? So let's go ahead and just do that custom test as well, and I'll show you the entire line here. So we're comparing the iPhone sitting to the rows with the iPhone walking, and it's a paired test. And this is back, this is still using our wide format table. So we run that, and we can see that in fact there is a significant difference. And in looking at the box plot for just those levels, we can see that in fact the sitting is in fact faster in light of their variance than the walking condition. So that's a way we've explored our interaction effects and our main effects between these keyboards for these different postures. Obviously, a set of findings like this would be a fascinating thing to look into further as to why the results are the way they are. Now we'll go, next we'll go into looking at a non-parametric approach for this. And so when we resume, we'll start there.